7.6 is common logarithms, and we know from before that a logarithm is talking about an exponent, okay? So I don't want to say a logarithm equals an exponent, but that's kind of what we're thinking about. When we're thinking about logarithms, we're also thinking about exponents. They are linked together, all right? And a common log, when they say common log, they mean base 10. So base 10 is the one that happens the most, I guess. All right. It happens so frequently that they call it common. All right. And so when you look at problem number 1, it says use a calculator to approximate each to the nearest thousandth, I guess. When it says just log, it means log base 10. We don't need to write that 10 in there, but that's what it is, okay? So if we're talking about a logarithm being an exponent, the question to ask yourself is what exponent would make 60? All right. So if you think about it, what's 10 to the first power? 1, right? We need some exponent that's going to make 60. What's 10 to the second power? 100, right? That's too big. We need an exponent that's going to make 60. So it's going to be in between 1 and 2 because 10 to the first is 10, which is too small. 10 to the second is 100, which is too big. All right. So how your calculator works, for base 10, it's easy because there's a button for base 10. There is a button, and it's just the button that says log. So find the button that says log, and you're going to type in log 60. Log 60, and you should get 1.778. So this question says round to the nearest thousandth. So 3 decimals, 1.778. That's it. That's the answer. Okay. And so if you think about what in the heck did we just find, we just found the exponent that makes 60. So how I could check my answer, I suppose, is I have a base 10. And if I took that to the 1.778 power, that's really, really close to 60, right? It's rounded because I rounded. I didn't type in 1.778. 15125. I didn't type in all of those numbers. I only rounded off. So of course my answer is a little bit off. All right. But what I'm looking for when I'm doing a logarithm, I'm looking for the exponent. Okay. So what exponent makes 6? All right. You could play like 10 to the first power is too big. So my answer has to be smaller than 1. If I said 10 to the 0.8, that's pretty close, right? But I don't have to do that. I don't have to hunt and, search for an exponent because I've got that log button. All you do here is log 6. 0.778. 0.778. Now it seems like this is easy, but it's going to get harder once we get out of the common log, out of base 10. Okay, so log 59, just type it in. Okay, log 59 means 1.771, 1.771. And again, what you're finding is the exponent, 10 to the 1.77085. That's going to equal 59, right? That exponent produces the 59. Now, here's what happens. When you get to problem number 7, you can't type it in to your calculator anymore, okay? Because you don't have a log base 5 button on your calculator. You have a log base 10 button on your calculator. If you think about it, I could have any number of bases, log base 5, log base 10, log base 17, log base 91, okay? There's an infinite number of different logs. You can't have that many buttons on your calculator, all right? So they only put 2 buttons on your calculator. There's log base 10, and then there's that LN button, which is something we'll talk about tomorrow, I think. All right. So here's what we have to do. We have to do something called the change of base, and this is important. If you don't do this, you're going to get pretty much every problem wrong. Okay. Change of base formula. Okay. all we have to do is, okay, and this is weird, all right. Well, first of all, try to think about it, okay? Can anybody think of an exponent that's going to make 32? 5 to the 5th power is, I don't know what that is. That's too big, though. 5 to the 2nd power is 25. That's pretty close. Yeah, right. 5 to the 2nd power is pretty close. 5 to the 3rd is 125. That's way too big. The answer is going to be in between 2 and 3 somewhere, right? Okay, it's going to be 2 point something, and you can kind of play around. 5 to the 2.1. That's too small. 5 to the 2.2. That's too big. So now we know it's in between 2.1 and 2.2 somewhere, right? Okay, but here's how you do it. Here's the change of base formula. What we're going to do is we're going to write log 32 divided by log 5. We use the log base 5, we change it into the common log, and that way we can type it in on our calculators. All right, that's the only way you're going to be able to type this in on your calculators, unless you might have a fancier calculator than I do. Some of your calculators you can type in the whole thing. Most of them you're going to have to use the change base formula. Log 32 divided by log 5 should give me a number between 2.1 and 2.2. Sure enough, it does. The answer is going to be 2.153. 2.153. Now again, what did we find? We found an exponent. We found the exponent that makes 32. All right, and again, we're only off because of rounding. So once you know that, you're in pretty good shape for the rest of the problems. We can just use that change of base formula. Log base 4 of 35, okay? Anybody know what it's between? What's the answer going to be between? Okay, what two numbers? That's correct. Nope. Four to the 2nd power is 16. That's too small. 4 to the 3rd power is 64. That's too big. We're looking for the exponent that's going to make 35. It's going to be 2 point something, right? It's going to be in between 2 and 3. But how we're going to do this on our calculator, quite simply, log 35 over log 4. That is the change of base formula. We are not dividing 35 by 4. That's not what we're doing. It's not 35 divided by 4. It's log 35 over log 4. 2.565. Yeah, rounded that one up. So we've got this now, right? Got the hang of it? Log 32 over log 4, 2.5. Okay. That one's a nice one. I think you've got the hang of it. Log 60 over log 5, 2.544. I do want to see this piece of work, though, by the way. Log 60 over log 5. I know it seems like, I know you don't need to. I know you don't need to, but that's how you would show your work for this problem. Okay, so the next one, log 5, log 8 over log 5. 1.292. 1.292. Okay, let me give you one that you should be able to do in your head. Okay, check it out. What's log base 2 of 8? That's 3, right? That's 3. Very good. All I'm saying is what exponent makes 8? And so sometimes you can do them in your head. If I said log base 5 of 25, What exponent makes 25? That's 2. Okay. Sometimes you can do it in your head, but when you can't, you've got the change of base formula. All right, now, oops, where are we at here? Come on. Just sit still. This is aggravating. Stop. Okay. Now, we're solving. Solving. 9 times out of 10 when we solve, we're just trying to isolate the variable. Okay? Isolate the variable. Now, what people are going to do on this problem is they're going to divide by 10, but that's not what this says. Okay? You don't get rid of a base 10 with a division problem. You get rid of multiplication with division. This is not going to be multiplication. This is not going to be division. I've got to get rid of a base 10, and that's where my logarithm comes in. Okay? Logarithms and exponentials are inverses of each other. So if I want to cancel out a base 10, I have to do a log base 10 on both sides. Now, log base 10 is just log. So I guess, I don't really need to write log base 10. I could just do a log. If I do a log, that is log base 10. And so that cancels this out and gives me n equals whatever log 7 is. Log 7, 0.845 or so. Round your answers. What does it say? Round your answers to the nearest 10,000th? 10,000th. Round your answer to the nearest 10,000th. That means 4 decimals. That's 4 decimal places. So 0.8451. N is about 0.8451. Okay. It's thousandth, 10,000, 100,000th, millionth. Yeah. Yeah, there you go. Okay. So next problem. Think about this in your head before you do the log. Okay. Is n equals 2 too big or too small? If I put a 2 right there, 10 squared is 100. That's too big. So my answer is definitely going to be less than 2. I can kind of see the future a little bit. I know my answer is going to be in between 1 and 2, but whatever. I don't really need to do that. I'm going to take a log on both sides. So n is going to equal whatever log 64 is. Log 64. Two, right? 1.8062. Log base 10. Remember, it's a log base 10. And so the log base 10 is what cancels out that base 10. Okay, this one's going to be different because it's not a base 10 anymore. All right, this is not a base 10. So we're still isolating. We're going to subtract this 3 and get 8 to the nth power equals 55. But this time I have to cancel out that base 8. And if I want to cancel out a base 8, I'm going to use a log base 8. Log base 8 on both sides. Okay, this is kind of the whole thing. N is going to equal whatever log base 8 of 55 is. This is where you have to use your change of base formula, right? You can't just type in log 55. That's going to be a common mistake. People will just type in log 55. That's not it. You're going to have to do the change of base and say log 55 over log 8. That is unless you have a special calculator that you can type it all in. Log 55 over log 8, 1.9271. Okay. 23, first thing, let's subtract this 9. 58 minus 9 is 49. We are not dividing by 14. We have to do a log. Specifically to cancel out this base 14, we have to use a log base 14. And so n is going to equal whatever log base 14 of 49 is. And so we use our change of base, log 49 over log 14, 1.4747. Okay. Next one. We know we're going to add 6, but that's not our first move. Okay, if we're really trying to isolate the variable, you can't get to the minus 6 until after you get rid of the base 12. So we need to do the base 12 first, and then we'll add 6. Has to do with the order of operations. We're undoing the order of operations. So the first thing I'll do here is a log base 12. Log base 12 first. That gets me the exponent, x minus 6. X minus 6 equals whatever this is, log base 12 of 80. Okay. So we're going to do our change of base, right? Log 80 over log 12, 1.7635. 1.765. Maybe we should make a note. Somebody get that for me, please. Log 80 over log 12. Okay. Now we can add the 6 over to isolate the variable. 7.7635. All right, good stuff. Good stuff. 27. We need to get rid of that base 4. Going to do a log base 4. I think we already did log base 4 of 32 on the other side. Does anybody remember what that was? Log 32 over log 4. That's right. 2.5. Okay. Again, in case you forget, we're doing the change of base formula. Log 32 over log 4. Got 2.5, but the last step, we need to isolate the variable, so we're going to subtract 8x equals 2.5 minus 8, negative 5.5. Okay. Is this the last one, 29? So we're just trying to isolate the variable, right? We're undoing stuff. Okay. So what? Anybody know what the first thing I'm going to have to do to undo? Very good. Let's get rid of this negative 7. So let's divide by negative 7. All right. And that's going to give me 6 to the 5x equals whatever that is, negative 12 over 7. I'd go ahead and do negative 12 over negative 7. So it's a really ugly decimal. I don't know that I would round off just yet. 1.71, 42857,143. When we round off, we don't really want to round off until the very end, okay? But you've got that number in your calculator. So if you've got that number in your calculator, a lot of times you can just use that number that's in your calculator. You don't necessarily have to write down the whole thing. But the next thing I need to do is get rid of my base 6. How do I get rid of my base 6? Log base 6, okay? We're going to use a log base 6 to cancel out that base 6. Okay? So watch what I'm going to do here. Watch what I'm going to do, okay? I've already got that big long number in there. I don't want to type it in because I'm lazy. I'm going to go log of answer divided by log 6. Okay, so I didn't have to type in that whole number. It's just going to pull it down for me. All right, is that what you guys got? 0.3-ish? 0.3? 0.30081967747. And then, of course, last step, I'm going to ISO. So I'm going to divide by 5. Divide by 5. So again, I don't want to have to type that whole number in. So I'm just going to hit divide by 5, and it just pulls my answer down and takes that whole thing. Okay. X is about 0.0602. 0602. There we go.